In this video, we are going to look at notes on the quadratic formula, and also in this video, we will wind up getting some complex solutions. Remember, complex numbers are numbers that sometimes have an I in them. So, we can solve quadratic equations by factoring and by using square roots. We also need to solve quadratic equations even when these methods do not work. By the way, we also know how to solve quadratic equations by graphing, where we graph and see where they cross the x-axis. So, if we can't solve a quadratic equation by one of these methods, that's where we like the quadratic formula. What does our hero, the quadratic formula, look like? Well, it looks like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. You will need to memorize this formula. I will give it to you on a formula sheet, but really you're going to work with it a lot. You're going to use it in your future. It is something you should have memorized in your math background. So, how can this be our hero? How can this help us? What are A, B, and C? How many solutions will we get? Where do we start? Well, we know what the standard form of a quadratic equation looks like. The standard form of a quadratic equation is, if I start with 0 equals, it could also be a y equals if I wanted to, I would have ax squared plus bx plus c. Whenever we're solving a quadratic equation, we need a 0 on one side of the equation. That means get everything on one side of the equal and have 0 on the other side. Additionally, the polynomial terms are written from highest degree to lowest degree. That means the x squared term comes first, then the x term, and then the constant. Let's do the U-try. Set up the following equation so we can use the quadratic formula. I need this to be in standard form, so I need to have it in the form of 0 equals ax squared plus bx plus c. In order to do that, I'm going to need to move some things around. I really prefer when my x squared term is positive, so I would move this 3x squared over to the left side of the equation. I also would need to move the 7 over to the left side of the equation. So on my left side of the equation, I have a 3x squared, a 5x, and a minus 7. I need to write them in order from the biggest exponent down. So I have my 3x squared first, then my 5x was positive, and when I moved the 7 over, it was subtracted. We need to realize that a, b, and c are just the coefficients. A is the coefficient of the x squared, which would be 3. B is the coefficient of x, which is positive 5. And c is the constant term on the end, so c would be equal to negative 7. Finally, we get to plug this information into the quadratic formula. Always start by writing down the quadratic formula, then plug in the a, b, and c. We're not going to solve this yet. We're just going to enter all the variables and plug them into the formula. Copying the quadratic formula from up above, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Make sure when you're drawing your top of your square root bar that it covers the whole thing, the b squared minus 4ac. So now, when I go to plug into my quadratic formula, I'm essentially going to have a whole bunch of spaces here where I need to replace an a b, or a c. The only thing that stays in my quadratic formula are the signs, the pluses and minuses, the squareds, and numbers. So, looking at my work that I have above, a is equal to 3, b is equal to 5, and c is equal to negative 7. The first thing I need in my quadratic formula is the opposite of b, so I would plug in a 5 for that b. Then I have plus or minus the square root of b squared. B again was 5, minus 4ac. A was 3, so I plug in a 3 for A, and C was negative 7, so I plug in a negative 7 for C. All of that was over 2A, where A again was 3. So I just used the numbers from my original quadratic equation I had up above and plugged them into the formula. Let's turn the page and do problem number 1 together. I'm supposed to solve 2x squared minus x minus 10 equals 0 using the quadratic formula. I'm going to show each step, and the reasons for words are going to be written on the right-hand side. I'm going to complete each box in the problem, and when I write my own reasons, I may need to make them more specific than those that have been provided. My first step was to write down the quadratic formula. That's x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now I need to substitute the values of a, b, and c into the quadratic formula. So looking at my original equation up here, I should realize that a was equal to 2, b is equal to -1, because the coefficient of x, if I don't write a number in there, it would need to be a 1, and c is equal to -10. So I'm going to plug into my formula. X equals the opposite of b. The opposite of -1 will wind up being +1, but I'll simplify that in a second. Then I have b squared minus 4ac. So I plugged in my numbers. All of that is over 2a. It's a good idea to write this step down. If you make a mistake simplifying, that's a lot less credit than if you just do the whole problem wrong. So showing our work helps us with that. In step C, I've got to look and see, what am I doing? What am I going to simplify next? Well, I said the opposite of -1 was +1. Underneath my square root, I did 1 squared was 1. That was actually -1 squared is 1, but it doesn't make a matter if b is positive or negative, because when I square it, it's always going to be positive. Following order of operations, after I do the exponents, I have to do the multiplication. So the next thing I'm doing in this problem is I'm multiplying together the 4, the a, and the c. So that gave me +80. I'm going to write down this step while I pause the video. So what did I do? Again, I simplified the opposite of b with the correct sign. I squared b and I multiplied the 4ac together. And realize when I'm doing that, I'm following the order of operations. I'm just doing PEMDAS to simplify. In step D, the only thing I'm combining is doing the b squared and the minus 4ac together to get one number underneath the square root. So I just wrote down that I did the addition under the square root. Now I'm going to scroll up some here. I have 1 plus or minus the square root of 81 over 4. Sometimes I might stop here because I might not be able to simplify any further. In this case, though, the square root of 81 can be simplified. How do I simplify the square root of 81? I want to break it down into its little factors, and I should be able to tell that the square root of 81 is 9. However you came up with that is fine. So I'm going to replace the square root of 81 with a 9. I'm just doing a substitution there. The square root of 81 is equal to 9. So now I have kind of a weird expression, 1 plus or minus 9 all over 4. This is two separate things. X is 1 plus 9 over 4, and also x is 1 minus 9 over 4. So what I'm going to do is I'm going to rewrite this, separating the plus or minus. So I should have two separate answers. Remember, a quadratic always has two answers. So that's where the two answers are coming from. My last step here is going to be to simplify each fraction and write each solution. So if I were simplifying this one, I would have 1 plus 9, which is 10, over 4. I could reduce a 2 from each of those to turn x into 5/2. My second solution, x was equal to 1 minus 9, which is -8. -8 over 4 is equal to -2. And these are my two solutions to the quadratic formula. X is equal to 5/2 and x is equal to -2. This is a lot of work for something that I could have done by factoring. Let's just verify if I solve this equation by factoring, what would happen. If I solve the same equation, 2x squared minus x minus 10 equals 0 by factoring, I'd be looking for what two things multiply to 20 and add to negative 1. I can go through the steps and factor that by grouping. And then, turning in blue down here, I set each factor equal to 0, and I wind up with x equals 5/2 and x equals negative 2. I also should realize if I had graphed this thing using my calculator, I would have had a root at x equals negative 2 and x equals 2.5, which is 5/2. So that's another verification that this works. Whether I solve by graphing, quadratic formula, factoring, it doesn't matter. The nice thing about the quadratic formula is that it always works. Sometimes factoring might be easier, but if you're not strong with factoring, the quadratic formula always works. Here's a try. Solve 3x squared equals 5x plus 2 using the quadratic formula. First thing we want to be sure of is that we move this 5x and this 2 over to the other side. So I'm going to solve the equation 3x squared. When I move the 5x over, it's minus 5x. When I move the 2 over, it's minus 2. And this is the equation that I'm going to be solving. I want you to pause the video while you do this try. You may need to do it on a sheet of notebook paper because this is taking up a lot of space. And then check the video after you've paused. So I had 3x squared minus 5x minus 2 when I wrote that in standard form and got everything on one side. So a was 3, b was negative 5, and c was negative 2. I wrote the quadratic formula down on my piece of paper, and then I started to plug in. I plugged in for b, I plugged in for b squared, for a, for c, and for a on the bottom. Following order of operations, when I went to simplify, I said the opposite of negative 5 is positive 5. And underneath my radical, I had to do exponents first. So negative 5 squared was 25. And then I had to do multiplication and division in order from left to right. So minus 4 times 3 times minus 2 is positive 24. And last thing in order of operations is to do the addition in the middle. So I have 25 plus 24 is 49, and 49 is what I have underneath the square root. Next step is to try and simplify what's underneath the square root. The square root of 49 is 7, so I could just do a simple substitution and replace the square root of 49 with 7. Next step, to break that expression into two parts. I have 5 plus or minus 7, so I break this into two parts. One where I have 5 plus 7 over 6, and a second where I have 5 minus 7 over 6. 5 plus 7 was 12, so I had 12 over 6, which reduced to 2. 5 minus 7 is negative 2, so I had negative 2 over 6, which reduces to negative 1/3. My quadratic has two solutions, x equals 2 and x equals negative 1/3. When I get nice rational answers like this, nice numbers that can be written as a fraction without any square root symbols left, that's a problem I could have solved by factoring. But remember, the quadratic formula always works. That's part of the reason we like it so much. Let's go back to the example on our paper. My equation for here is 2x squared plus 2x minus 9 equals 0. That's already written in standard form, so I'm good to go. First step is to write down the quadratic formula. I did that in box A. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. My next step is to substitute the values of a, b, and c into the quadratic formula. Looking at my original equation, a was equal to 2, b was equal to 2, and c was equal to negative 9 because those were the coefficients of a, b, and c. Notice a, b, and c are numbers. They do not have any x's left in them. I just used the numbers. Now I'm going to plug these values for a, b, and c into that quadratic formula. So I've plugged each of these values for a, b, and c into the quadratic formula. I'm going to scroll down. In my next step, I'm going to simplify. The opposite of 2 was negative 2, and I could put my 4 plus 72 together to get 76 underneath the square root. In step E, I need to write the square root of 76 in simplest radical form. So I'm going to try and break down 76. What can 76 factor into? Well, 2 goes into 76 38 times. 2 goes into 38 19 times. So I can take a 2 out, and I'd still have a 19 left inside. So now I rewrite this as negative 2 plus or minus 2 square roots of 19 all over 4. In the next step, I want to factor the GCF from the numerator. So in other words, I'm looking for, is there a number that I can reduce out of all of these parts from the numerator and the denominator? So I could take a negative 2, or I'll just take a positive 2 out at the top, which would make this negative 1 plus 1 square root of 19. If I write it like that, I can see that what I'm really going to do here is I'm going to reduce in step G the 2 and the 4. 2 goes into 2 one time, 2 goes into 4 two times. And then what I really have is negative 1 plus or minus the square root of 19 all over 2. My final step is to write this as two separate solutions. So I'm going to write this once as negative 1 minus the square root of 19 over 2. And then I'm going to write it as negative 1 plus the square root of 19 over 2. And that's my final answer. Those are irrational solutions. They cannot be simplified any further. I could give a decimal approximation, but I'd rather leave them as an exact answer with the square roots in there. Now flip over to the practice on the back page. It says, what are the solutions for each equation? Remember, solutions of an equation are things that make the values true for this equation. So what values can I plug in for x, or what does x equal, so that my equation is true? I'm going to use the quadratic formula and give exact simplified solutions. So let's start out back on this page and let's rewrite the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. For each of these equations, be sure we have them set up in standard form. In number 1, we're already in standard form, where a is negative 1, b is 7, and c is negative 3. For an equation like number 2, I'm going to need to move the 10 over to the other side, so my equation is x squared plus 6x minus 10 is equal to 0. Now I have a is 1, b is 6, and c is negative 10, and I'm ready to plug into the quadratic formula. For one like number 3, I'm set up in standard form, but I don't have 3 terms. If I wanted to rewrite this with 3 terms, the term I'm missing is the x term. So I could fill in 3x squared plus 0x plus 20 is equal to 0. On this equation, a is 3, b is 0, and c is 20. For number 4, I have to move some things over to the left side. I've got to move the 5 over, and I've got to move a 7x over. So in standard form, I have 2x squared. I have plus 7x because my x's can't combine with other things that don't have x's. And then my plus 1 and my minus 5 go together to give me a minus 4. On the right, these things would cancel out to give me a 0. So for this equation, in number 4, a is 2, b is 7, and c is negative 4. On number 6, I would move the 4x over to the other side by adding it, and write the terms in order with my x squared term first, and then my x term, and then my term without an x. I'd have 0 left on the right. So for this equation, a is 2, b is 4, and c is 3. Once we have a, b, and c down, remember they don't have any x's in them. We've taken all of our x's out. go ahead and pause the video while you plug in the quadratic formula and simplify these 5 problems. In number 1, when we plug into the quadratic formula, we wind up with this solution here, where x is equal to -7 plus or minus the square root of 37 all over -2. If this were given in a multiple choice format, these 2 negatives that are out in front here would probably be reduced to give us the second answer of x is 7 plus or minus the square root of 37 all over 2. The reason that I can take those 2 negatives out is because the middle term was a plus or minus, so I'm really, when I'm simplifying a negative out of all of those. I'm not going to be real picky about it, but we could also write this as 2 separate solutions, 7 plus the square root of 37 over 2, and 7 minus the square root of 37 over 2. If it's a solution set, my answer would be written in the curly brackets. For number 2, when I plug into the quadratic formula and reduce, I have where I can simplify and take a 2 out of all 3 terms once I've simplified my square root. So I can factor a 2 out of all of those numbers, and then my denominator is 1, so I don't bother to write it. My final answer is -3 plus or minus the square root of 19. Again, if I wanted to, I could write that as -3 plus the square root of 19, and a second solution of -3 minus the square root of 19. For number 3, I filled in my 0 for b, and in this equation, when I simplified, I wind up with a negative underneath the square root. So when I break down the square root of -240, that becomes 4i square root of 15. So this equation needs an I in the answer because it was the square root of a negative. We could never solve an equation like this by factoring because I don't have imaginaries when I'm doing my factor terms. I also could reduce the 4 and the 6 like I did in the last unit to make 2/3. I could write these all as one answer, or I could write them as 2 separate things. 2i square root of 15 over 3, or minus 2i square root of 15 over 3. In number 4, when I simplified underneath my square root, I had the square root of 81. The square root of 81 is 9, so I no longer had a square root left. This tells me I could have done this equation by factoring if I'd wanted to. It's really important for this problem that I break it into my 2 separate solutions where I write it once with the plus and once with the minus. Because now I can simplify each of those answers and I wind up with 1/2, or I wind up with -4. On number 5, I plug into the quadratic formula, and again in this one, I have a negative underneath my square root when I've simplified. When I simplify the square root of -8, it gives me 2i times the square root of 2. Again, in this problem, I can take a 2 out of all 3 terms, so I divide a 2 out of each of those, which gives me my final answer of -2 plus or minus I square root of 2 all over 2. Come into class tomorrow with any questions you have on this material.